Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at object slicing and we're going to dig a bit deeper into polymorphism. So here I've got a class called parent and it's got a method called print which outputs the text parent. And we've got a subclass of parent called child which also has an identical print method except that this outputs the text child. So if we create a reference to the parent type here, let's just call it maybe P1. So I'm going to make this a reference. And let's actually, before we do that, let's create a child instance here. So I'm going to call that, let's call that C1 maybe. Now I can take the reference to the parent type and point it at the child object. And then I can call the print method using that reference. So you might want to guess at what's going to happen here. So maybe you know the answer, maybe you don't. But what would you expect to happen here? Well, if we run this now, what we actually find is that we get the text parent being output. So this reference it refers to an object of type child, which should print child. But because we haven't made the function virtual, there's no lookup mechanism there for C++ to find the right method to call. So it ends up calling this function. If we add the keyword virtual here, C++ is going to create a table of function pointers that point to the appropriate functions for the right types of object. And now if we run this, now we do get child being output. So in my C++ beginners course, we saw that this works with pointers, and we call this polymorphism, where if you have a pointer to a parent class type, a superclass, then we can point that pointer at an instance, at any instance of any subclass, because the subclass is a kind of whatever the parent class is. And then, providing we've got virtual methods, providing the methods were declared virtual in the base class, in the superclass, we can then call methods on that pointer, and the right method will be invoked for the actual particular kind of the object, exactly as we've got here. So the thing that I didn't mention in the beginner's course that I'm thinking of going back and adding it because it's quite important, is that this works with references as well. You can take a reference to a parent class and make that refer to any object of any subclass, and providing you're working with virtual methods, you'll get the right method being called with that reference. Now we can also do something kind of surprising, which is that we can do this. We can say parent, let's call this P2 equals child, like that. Now we can call p2.print. So what does this actually do? Well, again, we're seeing the text parent being output. Now, what's actually happening here is you might recognize this as copy initialization. So if you declare a variable of some superclass type, and well, of any type actually, and you set it equal to some object, like this is instantiating an object. Even though we've got an equals sign here, an equals operator, assignment operator, that actually invokes the copy constructor. And we're invoking the implicit copy constructor here, but we can see that working if we define our own copy constructor in parent. So this is actually calling the parent class copy constructor. This warning here is just saying that I've got a virtual print, I've got a virtual method, happens to be called print, but I haven't defined a virtual destructor. So just to shut it up, although I don't intend to use this destructor, let's go ahead and define a virtual destructor to make it happy. There we go. So let's give this a copy constructor. So I'm going to create a constructor here, and I'm going to call this obviously parent, has to be called parent. And the parameter that it's going to take is going to be a const parent reference. That's what makes it a copy constructor, and I'll call that other. So we don't actually need to do anything with this because the parent class here doesn't have any variables anyway. But I'm just going to output some text here saying copy parent. so that we can see this copy constructor being run. Now if I build this, there's going to be an error. So if you want a little exercise here, then it's worth pausing the video, looking at this code, and see if you can spot why this is going to give me an error. And there's something about what I've done in these two classes, leaving aside this code here. This stuff doesn't matter. But these two classes in themselves, if I try to compile this, it will give me an error. Okay, so have a go at that if you want. And now I'm going to tell you the answer. So let's just build this and we'll see the error. What's actually happened is, when we try to create a child class here, a subclass, subclasses have to run the constructors of the parent classes in order to be instantiated. So when we define a subclass, we must either have a default constructor in the parent class, or else we must specify what constructor we want to run in the parent class, as we saw in the beginner's C++ tutorial. So to fix this, well, you see, when we define the copy constructor, we lose the implicit no parameter constructor, so we have to redefine that now. And in C++ 11 we could do this using the default keyword, but I'll just do this in the kind of old style. Okay, so now this compiles, and if we compile this and we run it, we can actually see that it says copy parent. So indeed, when we do this down here, we're running the parent copy constructor, and you can now see why this works. Because if you have a reference to a parent class, you can assign an object of any kind of subclass of that parent, of that superclass, to it, just like we've done here. And what does the copy constructor do? Well, it has a reference to the superclass type. So of course we can assign to it an object of the subclass type, so it makes sense that this will work. Now this gives rise to something called object slicing, because imagine that we've got a variable here. Let's call it, maybe I'll just call it 1 and I'll make it an integer. We can initialize that just to get rid of the warnings here. Let's just set it maybe to 0. We'll initialize it here as well, set that to 0, and I'll give child a private variable int2, like that. Now we can't initialize 1 here, so if I try to do this, whoops, not in print, that's ridiculous, but if I give it a constructor, so child, here's a constructor, I can't then initialize 1 in the parent class, because if you have a private variable, scope of that variable is limited to the class where it's defined. We've seen that before in the beginner's tutorial as well. And that's why when you create a child class, you automatically get the constructors of the parent class being run, because the parent class constructors can initialize private variables like this. But what we can and should do is initialize the variables that we have here in child in this child constructor. So this works. This is just an unused variable warning, which is going to go away when I build the project. But well, I guess it doesn't. Let's take a look. Yeah, it's still saying it's not used, but we won't worry about that. Now, if you think about what's happening here, when we assign the child object to the parent using the copy constructor, the copy constructor here, what can a copy constructor do? What should it do? What it should do is this. It should say that 1 equals other.1. So it should copy this parent object that's passed into it, but it can't copy 2, because of course it doesn't know you're going to pass in some subclass. You can make whatever subclass you want. It can't possibly know what subclasses you're going to create, and the copy constructor can't take account of what variables they have. So when we do this, we've actually got what we call object slicing, where we're actually slicing away the part of the child that basically is the parent, and the other stuff, like this 2 variable here in the child, that gets sliced off and thrown away when we do this. because we can't make any use of it here. We're purely initializing a class of the parent type. So this is known as object slicing, where we are upcasting, in effect. We say we're upcasting a child object to the parent type. Upcasting because you're going up the hierarchy, casting because we're changing one type to another, and that's what casting is. So that's it for this tutorial. This is just something to be aware of, really, and I wanted to go over it particularly because it kind of makes sense of this otherwise slightly strange situation. And you also see that, yes, if you have any kind of function that has a variable of a parent type, and as long as it's a reference or a pointer, yes, you can pass in an object of a child type to that function, whether it's a constructor or whatever it is. And this is just a manifestation of that occurring. If there's anything that you don't understand in this tutorial, I highly recommend typing this out yourself. So take it step by step, cover everything step by step, and work through it and think about it. Because as I always say, just thinking about this doesn't always help all that much. What you've got to do is you've got to type it and think about it as you type, but more typing than thinking. Because somehow I find that really, really helps you to understand it. After all, the meaning of these keywords and this syntax, it really only exists in the way it relates to other syntax and other keywords. So that the meaning of a keyword really only lies in how it's used, in other words. So for that reason, typing out and using it really helps you understand this stuff. Okay, so yeah, that's it for this tutorial. Until next time, happy coding.